In this lesson, we'll learn about writing equations for lines. This is the type of problem that we would see. It would say something like, what is the equation for the line? Very similarly, what we do is that we make a function table and we actually look at the points that are actually on the line. As you can see, when x equals 1, y equals 2. When x equals 2, y equals 3. And when x equals 3, y equals 4. So we'll go ahead and write those in here. 1, 2. That point 2, 3. And that other point 3, 4. Just as we did before when we were graphing these lines, when we knew the equation, we can put those ordered pairs there. Could have put those ordered pairs there first and then put it back into the equation. Then we have to really think, how is it that we get from one to the other? 1 to 2, and 2 to 3, and 3 to 4, and we have to make sure that it holds true for each of those lines. It looks like it's plus 1, and plus 1. So x plus y. Let's see, we have x and y, so it's y equaling x plus 1. And then we really look to make sure that's right. 1 plus 1 does equal 2. 2 plus 1 does equal 3. And 3 plus 1 does equal 4. This is the equation for the line. Y equals x plus 1. And what we could do is we could write it in here. This is the equation. Y equals x plus 1. That's the equation for the line. In some instances, they just give you a function table, and then they ask you to figure out the rule for that function table. And in this case, we're finding out the rule. That would be the graph of a line. Let's see, how do we get from 2 to 0? We can, looks like we can just subtract 2. Will that hold for the other ones? 3 minus 2, does that equal 1? Yes. Negative 2 minus 2 does equal negative 4. So we have the equation y equaling x minus 2. I'll give you one that's a little bit more difficult. We've got x and y here. Got 0, negative 1, 1, 1, and 2, 3. And then so, let's see, these here, for the y's, x is only going up by 1 each time. So you go from there to there. These, however, are going by 2, negative 1 to 1, and 1 to 3. And what this means is that we have multiplied x by 2 and then done something. Let's see, so we got y equals 2x. And 2x, 2 times 0 is 0. Minus 1 is negative 1. 2 times 1 is 2. Minus 1 is 1. So we'll go ahead and write minus 1 here. So this is our rule and our function rule. Y equals 2x minus 1. Here's another type of problem that you might see. You might see which is the function rule for the function table. So what you do is you can actually look at each of these here and check each value. We plug 2 in here. Oh, y equals 2 minus 2. Oh, it does equal 0. However, when we go like this for the 3, y equals 2 minus 3, 2 minus 3 does not give you 1. So this rule right here, y equals 2 minus x, does not hold. Next one we check is y equals 2 plus x. 2 plus 2 does not equal 0. Oh, so that second one does not hold. Y equals 2x also will not hold. The one that does hold is y equals x minus 2. And then let's go ahead and work that out and take a look at that. 2 minus 2 does equal 0. 3 minus 2 does equal 1. And 4 minus 2 does equal 2. So the function rule for the function table is y equals x minus 2. Here's one for you to try. Find the equation. Hit pause. Did you write y equals 2x? 2 times 2 does equal 4, 2 times 3 does equal 6, and 2 times 4 equals 8. I would have also accepted y equals x times 2, or y equals, let's see, 2 times x. And another way that we could have written this is y divided by 2 does equal x. Here's another one for you to try. Find the equation. I'll help you out a little bit. We'll go ahead and make that function table. And in making that function table, let's read out these points. This first point is at, 1, 0. The next point is at 2 and 3. So we'll use that point there. And the other point that we'll end up using is 3 and 6. Remember what I said about these here? When we get our x coordinates going up by 1 each time, each of these are going up by 3, meaning that we'll do y equals 3x. And then yet we're going to have to subtract a number from there. Can you figure out what that number is? 3 times 1 is, to get to 0. 3 times 2 is, and then make sure it works for each of those there. What did you come up with? Did you come up with 3? Y equals 3x minus 3 is our equation. Again, what we did is that we took each of those points that had fallen on that line, we put them into a function table, and then we looked at that relationship. When x increased by 1 here, this was increasing by 3. That's how it is that we got that there, of the y equals 3x. We still had to figure out the minus 3. That minus 3 actually should be right here, right on the line. Looks like our line was a little bit misdrawn. Again, using a ruler would have helped.